look at machine learning forecasting. It will begin in the Congo room pretty soon. So, our next speaker is Vinod, who's a senior data scientist. He will give us a 20-minute presentation on scaling AI in education, the importance of feedback loops in models and driving adoption.
Thanks. Hi everyone. My name is Vinod. I'm a data scientist at Coursera, and I'm going to talk to you about scaling AI in education and some of the lessons we've learned that I think are useful for anyone looking to apply AI in their business or product. So just by a show of hands, how many people here have heard of Coursera? How many people have enrolled in a course? How many people have completed a course? Now it's actually a lot more consistent than other places I've done this thing before. You'll see a huge drop off when I get to completion. But that's good that a lot of you are completing the course. So for those of you who aren't familiar, Coursera is the world's leading online platform for higher education. We serve tens of millions of learners around the world. And these are people looking to advance their skills in both courses and degrees. And we get this content from leading universities and companies as well. So we'll partner with universities like Stanford and Yale, but also work with companies like Google and PwC to create content. And our mission statement at Coursera is a bold one. We want to create a world where anyone, anywhere can transform their lives by accessing the world's best learning experience, right? And if you think about the tens of millions of learners we have around the world's best learning experience can mean many different things to different people because people have different backgrounds, different goals, different skill sets. And so when we talk about scaling education, we need to account for this personalization in what we do. But the problem we're trying to solve is becoming increasingly important, right? So like the rate of innovation is growing a lot because of technology and globalization, and by virtue of being in the conference, we all know the transformative impact that AI and machine learning can have. But what we're trying to do is we're trying to account for that and trying to use these technologies to create novel solutions to this emerging problem. And so at Coursera, we're trying to create our learning ecosystem that can tackle these challenges. So what we do is we bring learners who want to learn and prosper together on our platform with educators who want to teach the world, both universities and companies that want to transform their talent together into a single platform. When you think about all those players using the platform, there's a lot of data, explicit and implicit signals about what people want to do, what they're looking for, and that creates a lot of challenges to scale, right? But kind of like, anybody knows about machine learning and AI, when you have a lot of data, there's a lot of opportunity to apply those technologies to use your data to solve problems. So with data and with technology, the challenges of scale become opportunities. And so what I want to talk about today is kind of two case studies that illustrate some best practices that we learned when we think about building data products. And I'm going to talk about data products both to power the user experience, but also data products that can drive decision-making internally within your business. And the first case study is going to talk about the power of having feedback loops, and this is especially relevant for user-facing data products. I'm going to illustrate that through talking about Coursera's skills graph. And so here's a visualization of Coursera's skills graph. And so it's really just kind of a set of connections that map skills to the content that teaches those skills, to the careers that require those skills, and to the learners that need those skills. And this graph has a ton of connections, but for purposes of this section, I'm going to focus on this is taught by edge here. And this is really about mapping skills to the content that teaches them. I'm going to talk about how we created that edge and some of the lessons we learned as we were building it out. So when we first tried to map content to skills taught, we kind of proceeded like you would any normal classification problem. We first did the mapping using simple heuristics. So we would look for occurrences of skills in our content through occurrences in lecture transcripts, occurrences in assignments, and also occurrences in things like the course description and course title. And then once you kind of get that simple mapping, you then look for experts to kind of validate your tagging. So we went right to the instructors who taught the content and asked them, are the skills that are being most frequently mentioned in your content actually being taught or not? That created a supervised label. And then, we had the supervised label, we had the frequency occurrences as features, and could also use features from an embedding model and NLP, and then you get your nice classifier, right? And so in theory, you can take that classifier and then use it across all your skills and all your content to identify what's actually being taught or not, right? But it turns out that this approach actually had a couple of challenges to it. And The first challenge was that we had limited coverage of skills and courses, and we tried to source information from instructors. I think instructors are really busy, they have to teach, they have to do research, they have to go to conferences like these, and so we got pretty low response rates when we tried to source this information from instructors themselves. And then second, I think a lot of you might sort of understand this point back when you think about when you were in school. Instructors have a very different notion of skills than learners. So when you think about like computer science classes or data science classes, a lot of people might feel like, oh, I learned how to program in Python in that class, and that was a skill that was valuable. Or I learned this particular software package. Instructors don't see that stuff as skills. They see that as a tool to learn the skills and the theory of like the discipline that's taught in the course. And so because of these challenges, we tried to figure out how can we circumvent these. And the answer was that we would crowdsource it. We would go directly to our learners, and we would ask them what skills they learned. So now, as many of you have completed classes on Coursera, you might have seen that there's a pop-up when you finish the course that asks you what skills you learned. And so then learners will type it in and tell us directly. And then we would use this information in two ways. So when completers would say what skills they learned, it would when they told us what skills they learned, after sufficient learners named it as a skill, we would create a supervised label to try and predict, basically saying that we are completely sure that that skill is mapped to that course. And then we would also use the proportion of learners saying they learned that skill as a feature in the model. So the learner voice essentially becomes both an output and a predictor within the model. And then, once we kind of fit our model and got the output from it, and we're kind of got a sufficiently high predicted probability that that skill was mapped to that course, we would serve it back higher in autocomplete suggestions when learners were telling us what skills they learned. And so you kind of get this coherent feedback system here, where as more learners start naming a skill in a particular course, it creates a supervised label, you create a feature for it, it feeds back to autocomplete, and then more learners end up tagging it, and so you can really quickly get validation on whether a skill is taught or not through this system. So building feedback loops into the data product, it really allowed the customer voice to contribute and unlock applications. It contributed to the feedback loop because it was becoming both a feature and a predictor in the model, and it unlocked applications that I'll kind of go through now. So kind of going back to what I talked about when I said instructors didn't think tools or technologies were actually skills that people could learn in classes, that caused our initial set of skill to course mapping to miss out on a lot of these things. So if you looked at data science content on Coursera and looked at the skills that we thought were taught, you wouldn't see things like Python, NumPy, Pandas, scikit-learn. Those are all actually useful skills though. When we asked learners directly, they mentioned learning those skills, and because of the feedback loops, it got kind of bubbled up in our data and got tagged to those courses. And so now, because we kind of introduced the learner voice into the model through feedback loops, it unlocked skill discovery through tools and technologies on our platform. So now you can go to Coursera, you can type scikit-learn, and you can see all the courses that actually get taught by it. The other cool thing about feedback loops is because they factor in the customer voice, they can actually unlock unanticipated applications. So, when we were initially building our skills taxonomy, we kind of limited it to only technical skills because that's sort of what we're familiar with as data scientists. But Coursera itself offers courses across every single domain. So we offer courses in business, personal development, art, and history, all those things. And when we asked learners what skills they were learning in that content, they started to mention a lot of soft skills. So in a lot of our personal development content, for example, learners would say that they learned the skill of confidence. And because we have that feedback loop built in, those skills got added to our taxonomy, they got mapped to the courses that we're teaching them, and it unlocked this soft skill-based discovery on our platform. So now you can go and search Coursera for confidence, or leadership, or other soft skills, and then you'll actually see the courses that learners say teach those, serve to you. So one of the other benefits of building feedback loops into the data product is that it creates a nice scalable data asset that you can then leverage in downstream applications. So if we think back to the skills graph, so this skill to course mapping that I just talked about with the feedback loops is really about this is taught by edge. And because it has this nice feedback and sort of scales with our platform, as we add new courses or skills or new learners join, it just automatically collects data and improves itself, right? And so it's kind of like a self-sustaining segment of the graph that we can then kind of leave alone and spend our attention focusing on other areas and building out other applications. So as an example of some of the other applications that these feedback loops unlocked is we can take our skill to course mapping, combine it with assessment to skill mapping, and combine it with learner performance and assessments, and start to measure learner skill level using item response theory models. And we can measure skill level across many different subject areas, across many different skills, and that allows us to build things like learner skill profiles. And with learner skill profiles, you can start to understand, for example, this particular student in data science is stronger in data management, weaker in machine learning, and then we can use this to personalize recommendations for them based on skill level. And so we can recommend that particular learner who is weaker in machine learning, beginner machine learning content. But because now we have millions of learner skill profiles, and we also have additional information on what companies they work at through their Coursera profile or their social media linked accounts, we can start to sketch out company skill profiles and help companies kind of benchmark where their employees' performance is compared to others in a defined peer group. For example, if you're a retail company, you can compare yourself to US-based retail companies with over 5,000 employees and really get a sense of where your talent stacks up. So, all those applications were kind of unlocked by the fact that we built feedback loops into our initial data model that helped the feature scale with the platform. And because we added the customer voice as a feature through these feedback loops, it powered a lot of unexpected new applications, like skills-based discovery by tool or technology or by soft skills. And so just generally when you're having user-facing data products, feedback loops can really help you unlock these two advantages. So that was the kind of overview of the benefit and power of feedback loops and some of the lessons we've learned there. I want to turn now to talking about the value of interpretable models, illustrated by Coursera's degree at-risk model. So Coursera is not just about courses anymore. We offer online degrees today. So we have 12 online degrees from 8 different university partners, and kind of like our consumer base, we serve a very diverse audience across many different countries with thousands of learners. But in particular, I want to call your attention to that 90% retention rate. So that means that from year to year in our degree programs, 90% of students retain, right? But then there's that 10% that end up dropping out. And if we think about parallels to the real world, we kind of know that students can drop out for many different reasons, right? They could get busy, or they could find the degree programs no longer relevant for them, or many other things can come up. But when we think about serving a high-quality degree experience online, what we need to do is we need to kind of scale the support services at a reasonable cost. Because we're not going to be able to hire the amount of human labor to kind of replicate what you would get on campus. We have to do it through AI and machine learning-driven technologies. And when we think about scaling these support services, it's about answering 3 questions specifically. Who do you intervene with? When do you intervene with them? And how are you going to intervene with them? And this is kind of paralleled with any high-touch, high-value product. You're obviously going to have a combination of automated and human-led interventions, but you want to use machine learning to figure out who's really at risk and who do I need to escalate to like a human support system, or who can be served by automatic product features, right? It's really about sort of distinguishing between those 2 things. And so in the degrees context, kind of if you have more automated features, these can be things like in the product, you can have pop-ups saying like, hey, you should stay on track, or like, don't worry if you fail this assignment. You can link them to help articles that you think might be relevant for them. You could send emails to prompt them and remind them. But then you want to also escalate, if you have to a human-led team for the actual support. And so the first step in scaling these services and answering these questions of who, when, and how, it's really about building a good retention model to identify who is at risk and how it was targeted. And a good retention model should really do 2 things. One is it should accurately predict who is at risk, and 2, the model output should be interpretable so that when you have to scale, when you have to kind of escalate it to human-led intervention, the end users there are able to understand why the prediction is being made and how they should intervene. And this interpretability can also inform the automated interventions that you serve. And I'll kind of give a couple of examples of this. And generally in machine learning, there's a trade-off between predictive accuracy and interpretability. I mean, there's been a lot of work recently around like line, shapely values, but these aren't quite at the state where a non-technical person can really understand what these are. So on the back end, our at-risk model uses a variant coefficient model, and this allows us to kind of make predictions over time and understand at any point in a course if someone is at risk of dropping out or not. And so what we do with our at-risk model is we take the predicted completion rates at each point in time and tier them to aid in interpretability. And so we tier them into highly at risk, not kind of at risk, and then not at all at risk. And we use these to inform the interventions. And what we do with this back-end model output is we built a front-end dashboard that end users can kind of take and think about how should I intervene for these particular students. So these dashboards will show the predicted completion rate, the different at-risk tiers, so high, medium, or low, and then the values of the features that go into the model, and then also the feature importance of the different features. And then what we'll do is we'll kind of take these at-risk tiers and then use these to decide how to intervene. So for a student that is not at risk, is tier 1 in green. We won't do any intervention because they're on track, they're doing totally fine. For tier 2 medium at risk, we will send an automated reminder email. And we'll do automated interventions that way. And because we can get feature importance from our model, because we use sort of a linear model that's very easy to extract feature importance from, we'll tailor the automated reminder emails to the features that are driving the prediction. So for example, if a model says a student is at risk of not completing because they're behind, we'll kind of say, hey, you need to be on track, you should complete these assignments by this date. So we'll inform the content of the email by the reasons that they're at risk. And then finally, for students who are highly at risk, this is where we'll escalate to a human-led decision support. And so then the humans will be able to figure out how they should intervene based on the feature importance. And so to summarize, for data products driving decision making, interpretable models can more readily expose reasons for predictions, and that can both help you drive adoption among end users and inform potential intervention strategies through easily extracting feature importance. And so just a kind of summary of the learnings that I've gone through. For user-facing data products, feedback loops are great in scaling data collection, and they can also unlock unanticipated downstream applications because you have a nice core data set that will scale with your platform. For interpretable models, they are really about driving adoption and informing intervention strategies through feature importance. Thank you. Decide what course to launch? Okay, so the question is, how do we decide what content to launch before feedback? So we use a combination of, like we have a machine learning model that basically tries to predict based on historical data, how likely we think content, how well we think content will perform if we were to launch it. So we'll use a lot of, past data to inform that. I think we'll also use a lot of external research to bring in more like off-platform data. So what are the labor market trends, kind of job openings, things like that. And then we'll also survey learners directly about like what content do they feel is missing from our platform, what skills do they want to learn, do we have those skills on our platform or not. And then we'll kind of combine those three pieces of information together to make informed decisions. It's not completely driven by AI or automated, but it uses some machine learning in there also with human research. Question? Okay.
Okay, I think this is a great framework or model that gives insights to a student. It's very, very useful for us to adjust the courses we're going to take, how the careers are going to shape up, what's there on the market. But sometimes, at the rate that AI is penetrating in the industry globally, our jobs are going to change. The future of work is coming. So, are you giving some feedback to the university to upgrade their courses as well? By the time our students graduate, their course or their degree will become obsolete.
Yeah.
The job they're looking for.
So the question is, how do we kind of ensure our content is up to date for like the fast-changing nature of like data science skills or computer science skills and the like? I think there's like I guess two pieces to university content you can think. One is like the evergreen skills in terms of like how do I think about coding effectively, what are some best practices for designing code, what are some like useful algorithms that you can apply in different contexts, and then there's like the tools or technologies, right? And these evergreen skills that universities teach are kind of constant, they don't really change as quickly, but the tools or technologies definitely change super quickly. And so I think one of the nice things about Coursera is that because we have content produced both by universities and industry partners, we can kind of tap into both of those things. So the universities can teach the evergreen skills, right? Like you can learn machine learning from Andrew Ng. Like the basic principles of machine learning haven't changed since, I don't know when machine learning was first invented, like the 1970s or so. But the tools and technologies and programming languages are changing super quickly. So that's where having a content partner like Google, can come to our platform, teach the latest things around like Keras, TensorFlow, how they use machine learning, how they operationalize it. And so by having both these content partners, you kind of get the best practices and best attributes of both.
Let me ask you a question. Is your platform also linked to social media, like LinkedIn, for each and every user? Do you learn from that as well?
Users can connect their social media platforms to our data, so we sometimes get data that way. They can also like share their accomplishments and certificates on the platform, but we're not like directly integrated with it.
So you can learn, for example, from the things they posted or any updates? flash up on LinkedIn, you cannot learn from that.
No, we haven't integrated to get that data yet.
Okay. All right, thank you.
Your skills graph, there are skills that learner needs or employer hires for. There's no connection from the employee to the companies. And you mentioned that you have the company information also. Is there any data that skills needed, but skills help to get this job or company hired because of that skill? Like an action result for it?
Yeah, so the question is kind of how do we know what skills people might need at particular companies, and how do we kind of factor that information in?
Oh, that skill that they took through Coursera helped them to get that particular.
Oh, so how do we track like outcomes, for example?
Outcomes.
Yeah, got it. Okay, yeah. So outcomes is something we are very invested in our business and understanding. We want to make sure we're delivering a high-value product. Right now, the way we track outcomes is we do it through learner surveys. That's kind of the best way we've come up with right now. So on the consumer side, 6 months after you complete a course, you'll get a long-term outcome survey that will ask you what were your objectives going into the course, kind of what outcomes have you had, either education or career-based, and then did you find the course was valuable, things like that, right? And then we'll analyze that data and track it over time to kind of ensure either it's going up or at least it's not going down, and then we'll use that to inform our product and iterate from there.
So from that, can you pinpoint which skills help the most to get hired?
Yeah, so the question is, can we pinpoint from that survey data what skills got them hired the most? And we don't directly pinpoint the skills, but we'll pinpoint the content. And because we can pinpoint the content, at that point we can pinpoint which skills were inferred to be super valuable, but also because we have companies using our platform to train their employees, we can figure out what skills companies are looking for. And that also kind of directly feeds into which skills are in demand and that learners should look to learn to get the largest impact.